All right, welcome back to our Ignite Hybrid Cloud series on Tanzu Mission Control for solution providers. So in this module, we're going to take a look at the workflow for attaching existing Kubernetes clusters, which allows our solution providers and customers to manage their entire fleet of Kubernetes clusters, no matter what infrastructure they're running on. So not only can Tanzu Mission Control provide the ability to provision net new Kubernetes clusters, but it also can attach to any existing cloud native compute foundation conformant Kubernetes cluster, no matter where it's running. Without further ado, we're going to have a look at the Tanzu Mission Control web portal, give a look and a quick tour of the web UI, and go through the workflow for attaching Kubernetes clusters to Tanzu Mission Control. So this gives us a high-level view of all the clusters in our environment across multiple clouds. We can have a look at the different providers for each of our clusters. So this is an AWS cluster here, our AWS Dev 1 cluster. We also have a couple of clusters running on vSphere environments. We even have a GKE cluster as well as a Red Hat OpenShift cluster under the control of our Tanzu Mission Control. We also see that these clusters, some of them are attached state, like our GKE and OpenShift clusters, as well as some vSphere clusters. This means the clusters existed previous to TMC, or we've attached them and they're not managed, or the lifecycle or provisioning process is not managed by TMC. Up at the top, we have a couple of AWS clusters that have actually been provisioned by Tanzu Mission Control, and they are the type provision. We can also have a look at other kind of quick level and high level information. We can see the status of our cluster, the health of the components of our cluster, also the Kubernetes version running in our clusters, as well as allocated memory, allocated CPU, and the node count in our clusters. We also have the ability to label and tag these clusters when we provision and or attach them to TMC. So these are key value pairs, just like you would see in the Kubernetes world. So we'll have a look at the AWS prod instance. We click on the cluster, and this brings us to a description page that shows us information about the cluster group, which we'll talk about a little bit later, the provider, again, the version of Kubernetes, as well as the AWS region that the service is deployed to. We can see the number of control planes, worker nodes, namespaces, pods, the total memory and cores across the entire cluster, as well as the accounts that were used to provision. We can also see the allocated CPU and memory, as well as component health and health of the worker nodes of the environment. We also see the health of the TMC agents that are running within the cluster. These agents report back information about the cluster to TMC to give us the view that we see today. We can also have a look at the inspection history. So we use open source Sonabuoy to run inspections in TMC. If we click on the nodes section, we can look at information about our control plane and worker nodes. So if we click on one of our worker nodes, we can see workloads that are actually running on the node, as well as the conditions of the nodes itself to kind of examine the health of and the status of that node. We can also see the kubelet and kubeproxy version, as well as the OS image and container runtime deployed on the worker node. So it gives us a little bit of information about the infrastructure. We can also have a look at node pools. So in provision clusters, node pools are just groups of worker nodes that we can provision in specific availability zones. We can actually scale these up and down. We can add a new node pool and a new availability zone if we'd like to have kind of our workload spread across AZs and AWS. We can also view namespaces in the cluster. We can create namespaces in the TMC cluster or in the AWS cluster via TMC. And if we click on a namespace, we can also gather information about all the pods and services running in that namespace and see CPU and memory usage across the namespace as well. We can also drill down and have a look at all of the workloads, pods, deployments, replica sets running in the cluster in totality, as opposed to looking at them on the namespace level. So this just gives us a quick level view of the health of our workloads and what namespaces they're running in. And then finally, again, we can see our Sonabuoy inspections that have run in the past. So if I click back on the cluster page again, we're brought back to our home page, and I'm going to go through the attach workflow. So this is an existing cluster, the workflow for attaching an existing cluster in the environment. So after clicking the attach button, I select a cluster group. So cluster groups are a way to logically separate clusters for users and teams. So I, as the operations admin, have set up an Ignite cluster group. I'm going to add clusters to that group and then assign my Ignite team access to those clusters. So when they log into the TMC portal, they only see and only have access to those clusters. So I'm going to give our cluster a name, and this is going to be a TKG cluster running in the Project Pacific beta environment in my lab. So Ignite TKG cluster is just the name of my cluster. I'm going to give a brief description of the cluster. This can be edited after the fact, and it's optional. And I also personally like to use key value pairs, at least for location. So what lab environment these services and clusters are running in, as well as the provider. So WCP, or the Workload Control Platform, is the code name for vSphere with Kubernetes in the beta. So those are the two labels I'm going to apply. So TMC will spit out a YAML file and a kubectl command that we will copy from the portal and utilize this command, this kubectl command, to run on our Project Pacific TKG cluster to attach that cluster to the TMC instance. So we can see we have a single control plane, 2 worker cluster. So we'll run that kubectl create command, and all of these resources are created. So we obviously get a VMware system TMC namespace created, a couple of config maps and secrets, some CRDs, service accounts, some RBAC resources, deployments, pods, services, etc., etc. So these services running in the cluster now give TMC, push information from the cluster to TMC that we're able to see and observe in the portal. So if we now verify that the pods are running in the namespace, we can use our kubectl command to verify that the pods are running. We still see we have a couple of containers creating after we ran the command, but that's okay. We'll give those pods a little bit more time to come online to start reporting status back to TMC. But here are some of the agents that are running in the cluster. So cluster health extension gives us information about the health of our components. Inspection extension is responsible for running Sonobuoy inspections when required. Policy sync extension grabs policies that are defined in the TMC portal. So we verify the connection in the portal. We've got good news. We've got the cluster connection established. And so if we click on continue, this will bring us to that same cluster overview page. And so we still are waiting for some of the TMC pods and components to come online. But eventually we'll refresh and we should see the component health fields stabilized and showing healthy nodes. But as you can see, this is similar to what we saw with our provisioned AWS cluster, but this is obviously an attached cluster, but we still get that same level of observability and information about our cluster. We can also extend policy and run an inspection on that cluster as well. So even though this was an attached cluster, we still can run a conformance inspection on the cluster. And we also have a roadmap for basically being able to schedule or set policy on inspections. So for instance, any cluster I attach or provision automatically has an inspection run on the cluster. So we're running this inspection now on the cluster. If we come back, oh great, we can see that the component health is all showing healthy status. And we see our inspections running in the bottom left-hand corner. So that concludes our lesson for managing any cluster with TMC and the attached workflow. So join us in our next session where we will focus on the workflow for actually provisioning a TKG cluster on AWS via Tanzu Mission Control. Thank you.